Maybe I'll pause and just talk about logistics. Okay. So our last step, well, one of our last things here is to actually determine, we have to determine is the data that we collect, is it normally distributed? Okay, does it follow the empirical rule? And some of the things that we're looking for is, right, to recognize is obviously 100% of the data is under the curve. The graph will be symmetric. The mean is at the center. Half of the values are below, half of them are above. These are all indicators that tell us that. But this is the one here that we're going to focus on the most, this one. It follows the 68, 95, 99.7 rule, the empirical rule. Another thing that you should observe if data is normally distributed is that the mean, the median, and the mode are equal or are very close to each other. That is also a very good indicator that data is going to be normally distributed. Okay. All right. So this is the important one right here. Like the empirical rule is check this. Okay, check this. That's what we're going to check for to make sure we make our decision. Okay, before we make our decision. So sometimes I will ask you, right? Like I'll just be giving a graph, right? And you can kind of tell, like you could look at this, and if you connected the midpoints, okay, that is basically what we do with data. We make bar graphs and whatnot, and then we connect them to make our frequency polygon, and we try to see, does this kind of follow a bell curve? It's not always perfect, but that's what we're kind of looking for. This one, probably, if we did the math, if we checked, it may actually approximate a normal distribution. This one for here is definitely not normally distributed, because if you connect the midpoints, okay, you're going to see that it's skewed, okay, not normally distributed. Graph shows data skewed to the right. This graph could be considered to be normally distributed because it approximates a bell curve. So I purposely picked data that isn't perfect, but we're going to check for that. Okay? All right. Steps to follow when you want to check. If I ask you to check whether or not data is normally distributed. Yeah, go ahead. Steps to show, okay? And these are just because students asked for steps. Students love steps, okay? Determine the mean and the standard deviation. Like that's step number one. sort data if possible. Okay, so we want to find the mean and the standard deviation, sort if possible. Create a frequency line. Okay, this one may be new, so I'm going to do frequency line, where the middle is the mean, and then add 3 standard deviations to the right, 3 standard deviations to the left. Fill in the bins created in step 1. So for what I will show you is this. I'm going to grab a ruler, and I'm going to give you an example. My mean is in the middle here, and then you go 3 to the right, 3 to the left. You don't have to. I don't care about the scale. I don't care about how pretty this looks. This is just for us to collect our data. Okay? Can I do an example? I'm going to go example. Let's use easy numbers. Our average is 50, and our standard deviation is 5. Let's just say, for instance. Then you would go 50, 55, 60, 65. 45, 40, 35. This is my mean, right? The middle. And I actually make bins like this. That's what I mean by bins. You have 6 bins that you've created. You're going to go to your data, and you're going to place them in there. It's almost like a frequency table. Remember a frequency table, right? It's almost like it, but I just like to be bins, and then we're going to go through our numbers and put them in here, and we're going to add it up. That's step number 3. And the last one, why is it another 3? Should be 4. Check if data follows the 68, 95, 99.7 rule. Okay, so check to see if data is 68 is within 1 standard deviation, 95 is within 2, 3 standard deviation 99%. Here, this is something worth highlighting. This is just something that I'm going to use. If data is off by more than 5%, we say that it does not follow the rule. That is the key here. More than 5%. Go ahead. Let's try one. 45. I would say have this in your study sheet, but make it really small. Right? Like just have the 4 steps so that you know what to do if I ever ask you for it. So here we go. I'm going to ask you to type all of these into your L1 right now. These represent movie collections, and it's the length of each movie. So let's type it all into L1. Just click away. Let's see if you can beat me to it. Just typing in all the numbers on page 45. kept recording. All right, so if you type them in, we can sort them right away because it's not a frequency table, so it's, oops, feed it L1, sort it, and let's find the mean, median, mode, and standard deviation. It asks us to solve for all of them, but if I didn't ask you, you for sure wanted to figure out mean and standard deviation right off the top. Okay, that is a given. So let's go ahead and find that out. For A, I go one variable stats, L1, right? And I get that my mean is 102.5 minutes. My standard deviation is 24.73 minutes. Very important. My median, the question is going to give me that. That's 99 minutes. What is it asking for? Mode. Do you remember how to figure out the mode? It's sorted, right? You just go to your L1. Sorry if you're still copying, my bad. There we go. If you go to your sorted list, just go look for it. There's 1, 2, 3, 4, 4 89s. I'm going to write that down for now. 1, 2, 2 90s. No, that's not it. 91, 2 of them. 2 94s. 96, there's 3 of them. 99, there's 4 of 99-minute, 4 99-minute movies, so that's also 1. And there is 4 100-minute movies. That's another 1. I believe that the rest are not contenders. So there you go. You've got 3 modes. You've got 3 modes in this case, so be ready for that one. Create a frequency table using the standard deviation as the interval width. I will tell you this, whenever I ask you for the frequency table, use frequency line instead. Frequency line instead. That's my way to make it faster. It's a lot faster if you do that. So again, if you have a ruler, I'm going to make my bin. This is for B. Make the bin. You've got your make those bins. It doesn't have to be pretty. And then you start with your mean in the middle, which is 102.5. And we're going to add a standard deviation every time. Just like before. This is almost like drawing your normal curve, right? So I would strongly recommend you use your calculator for this part. And what's my standard deviation? 24.73, correct? So you go 102.5 plus 24.73. That makes this 127.23. You keep adding another standard deviation. 151.96 and another one. 176.69. And you do the same thing going this way. 102.5 minus 24.73. That's 77.77. The next one is 53.04. And it's 28.31. if you need to add a standard deviation to either side to have more, because sometimes your data points are not going to fall in one of these bins, that is okay as well. So you've got 6 bins that we're going to place these values into. So this takes some time if it's this many values. So what I want you to do right now is I want you to, you would want to do this, right? Grab your calculator, you go to Stat, Edit, it's already sorted. 25, where does 25 fall in? Does it fall in this bin here between 28 and 53? No, so just put it here. It's 25. Then 73, 73 goes in where? In here, correct? Between 53 and 77? 78. Oh, 78 goes already in the other one. Right? It goes into 77 and 102. 78, 81, 84, 86, 87, 87, 88. Take your time. 89, 89, 89, 89, 90, 90, 91, 91. So now we're 15 values in there already. 94, 94, 95, 96, 96, 96, 98, 99, 99, 99, another 99, 100, 100, 100, 100, 101, that's still in here, right? 101, 102, we're still in there. 102, 103. Now we're jumping. 103 is past 102, right? So 103 needs to be in here. So 103, 105, 106, 110, 117, 122, 125, 129. I'm past this, so I'm no longer in this bin. 129, 135, 144, 154, I got to jump in here. 155, 162, 180. I'm jumping outside the bin over here. So I have one on either end that are outside my 3 standard deviations. That's fine. And what I like to do is I like to just go 1, 0, 1. This is 10, 15, 20, 25, 34. There's 7, 3, 3, and 1. Okay. So these are outliers, right? There's one that's really short, one that's really long. Just put them outside those bins. That's fine. Now, we're going to skip the creating a histogram. Okay, actually cross that out. I will never ask you to do that in this situation. Are the lengths of the movies normally distributed? So I want you to make sure you copy this down first. So if you're still copying, make sure you have all those values in there. And now we're going to check. This is D, check. We're going to go check for plus or minus 1 standard deviation. How many values do we have in total? How many movies? 50, right? So we're going to see for every single one, we're going to see out of 50 how many movies are found within 1 standard deviation, how many movies are found within 2 standard deviations, and how many movies are found within 3 standard deviations. I'm going to use some color here. 1 standard deviation if this is your mean, then within one standard deviation, we would want to look for one to the left and one to the right. So we're actually interested in this chunk right here. Okay, so 34 and 7, we have 41 out of 50. You go, all right, you got 41 divided by 50, that times 100, that's 82%. Versus, what is it supposed to be? Right, we're checking it against 68%. And this is way off. This is over by more than 5%. Like if you're off by more than 5%, it's a no-go, okay? So this is fails since we are off by more than 5%. That's the reason why I will say we're failing. But let's keep checking. Let's say this one would have passed. Can we keep checking? So if 2 standard deviations, I'm going to use a different color. Let's go orange here. 2 standard deviations from the mean. I'm going back 2 and over 2 to the right. So I'm actually interested in this, all of the values that are within 2 standard deviations. And that would be, this is 41, we know that already. So just add 1 and 3 to it, but I'm going to show you the whole thing. 1 plus 34 plus 7 plus 3. That ends up being 45 out of 50, which is 90%, versus 95%. This one actually does pass. This one fails. But the second one would actually pass because we're still within the 5% threshold. And the last one, is it too colorful? The last one is 3 standard deviations. We're actually interested in all of this here. Right? Like 3 standard deviations to the right and 3 to the left of the mean. That is everything but 2 movies. That adds up to 48, which ends up being 96%. Versus, what's the last one supposed to be? 99.7, right? That's our, it does pass that test. So the ultimate answer is it does not follow a normal distribution because of this, okay? Does not, data, I will say this, data is not normally distributed. That's what I'm going to say. Comma, since it does not follow the 68, 95, 99.7 rule. That is like the final statement you have to get this right. Let me just check here. 47. One second, 47. sorry, it's small, but page 47 and 49. One is normally distributed, one is not. That way you have, I will post more questions if you'd like to try more. Oh.